All right, so let's look at an example that has an infinite number involved in it. So let's say that h, so let's, come on, Ben. Say that h is a infinite number. So h, we'll use our notation. So h is an infinite number. Let's go ahead and make it positive infinite. And we want to know what the standard part of, say, 8h squared plus 3h minus 5, all divided by, oops, come on, oh my goodness. Screen's going out of control, sorry about that. All right, so we'll divide this, say, by 4h squared minus 8. So this is what we want to look at. Now, if this is an infinite number, then we actually can't calculate the standard part. There is no standard part of an infinite number. It's not defined. It's not in the domain of the standard part. But if it's real, then we're in a good position. Sorry, if it's finite, we're in a good position. So just like we did in the last section, we've got to first do some algebra here to make sure we can even calculate the standard part of this hyperreal number. And as I suggested in the video, when we're dealing with infinite numbers, the standard approach would be to factor out the largest power of your infinite number in both the numerator and the denominator. So we see we have an h squared here, an h squared here. So I'm going to factor that out. So this is equal to standard part, assuming it exists. We still don't know if it exists, but if it does, it's going to be the same. I'll factor out an h squared there. And I get an h minus 3 over h minus 5 over h. And then on the bottom, I'll still factor out the h squared. And I get 4 minus 8 over h squared. These guys cancel, which is why I factored it out. And now notice that I've got rid of all infinite expressions. This is finite, finite, finite. Everything is finite. So I can use my rules with infinitesimals. And just kind of taking a quick look at the bottom, this is 4 minus, now this is going to be an infinitesimal. So 4 minus an infinitesimal is going to, well, you'll get used to this, but you should see this standard part's going to be 8. But we'll go slow and get it. But nonetheless, it's not 0. Or sorry, not 8, but 4. So this is equal to the standard part of 8 minus the standard part of 3 over h, which is an infinitesimal, minus the standard part of 5 over h squared, all divided by the standard part of 4 minus the standard part of 8 over h squared. Now the standard part of 8 is 8. The standard part of this is an infinitesimal because h is an infinite number, so 3 over h is an infinitesimal, and its standard part is 0. Same here. H squared is an infinite number, so its reciprocal is an infinitesimal, hence standard part 0, and this is standard part 4. So I end up with 8 over 4, or 2. So let's scroll down and get to another, some more screen and get to another problem. So getting our new screen, let's look at the problem where standard part, say of A, is equal to 2, and the standard part of B is, say, equal to 7. So that's given to us, And we want to compute then the standard part of, let's say, 3a squared plus 2b minus 1 divided by maybe 2b squared plus 4a plus 3. So we're going to look at this standard part. And then we'll have to take a chance that maybe that we're dividing by 0, and we'll have to backtrack. But right now we'll just use the division rule. And so this is equal to the standard part of 3a squared plus 2b minus 1, all divided by the standard part of 2b squared plus 4a plus 3. And run through all of the distributes across additions, distributes across multiplication, distributes across powers. So I can, hopefully you can see that this is the standard part of 3 times the standard part of a squared plus 2, or standard part of 2, times the standard part of b minus the standard part of 1, all divided by standard part of 2, standard part of b squared, plus standard part of 4, standard part of a, plus standard part of 3. Now we've got it all simplified down, and we don't know what a is, but we know its standard part is 2. We don't know what b is, we know its standard part is 7. And the other values we can calculate. So the standard part of 3 is 3. So this is going to be 3 times standard part of a, which is 2, quantity squared, plus 2 times the standard part of b, which is 7, minus 1, all divided by 2 times 7 quantity squared, plus 4 times 2 plus 3. Now we're all in the reals. We can calculate what this is, and it's going to be 25 over 109. Now, with the standard part, I couldn't just stick a 2 in for A and a 7 in for B. It would work in this problem, but there are other problems that we could devise in which that would give you an erroneous answer. So it's you've got to use the rules of standard parts first before you can go off and then plug values in. Let's do a couple more. Let's say x is a real number. So it's a real number. It's some arbitrary real number, and delta x is an infinitesimal, not 0, however. So it would be some infinitesimal other than 0. So let's look at what the standard part of, let's say, x plus delta x squared minus x squared, all divided by delta x. Now, delta x isn't 0, so I can do this division, but I can't use the standard part where I come across and divide or break this up in division because the standard part of delta x is 0. So just like before, I'm going to have to do the algebra inside. And so this is the standard part. So I can't distribute yet, but I'll multiply this out. So this is x squared plus 2x delta x minus, plus delta x squared minus x squared, all divided by delta x. And that can get my x squared and minus x squared, they cancel out. So we get some canceling there. That's the only thing that cancels, so I get standard part of 2x delta x plus delta x squared divided by delta x. And now notice that I've got delta x's in both of my terms on the top and in my term on the bottom. And so I can do some simplifying. This delta x will cancel with this one and reduces this power down by 1. And so I am now looking at the standard part of, simply 2x plus delta x. Scroll down, and that is going to be the standard part because it distributes across addition, and so it's going to be the standard part of 2x plus the standard part of delta x. This is 0, and we know that x is a real number from the very beginning. X is a real number, so 2 times x is still a real number, and it is infinitely close to itself. So the standard part of 2x is 2x. And if you've taken calculus before, or you should recognize that really what we're looking at here, this is the difference quotient of the function x squared. So in fact, what we're looking at is related directly to the derivative, or instantaneous rates of change. And we'll really explore this and use this definition to our benefit in the next chapter. But hopefully you can see what the standard part is going to allow us to compute derivatives. If you've seen calculus, you recognize, oh, yeah, the derivative of x squared is 2x. If you've not taken calculus before, you've never seen that, that's fine. You'll get plenty of it. So I think those are enough examples. They can get you started. Just like with the classification, standard part takes a lot of practice. It's tightly related to classifying. So if you can classify quickly, you can compute standard parts quickly, and it is very important to your future in this class and Calculus 1. So a little bit of time investment is your friend.